You know, you always hear about microplastics out in the ocean, right?
Right.
But it turns out that's really just scratching the surface.
Yeah, it's way more pervasive than just the oceans.
We're actually finding these tiny, tiny plastic bits in some, well, pretty shocking places, like human blood, our lungs.
Even the placenta, breast milk, infant feces. It's quite startling when you list it out.
Exactly. It makes you just stop and think, okay, we really need to unpack this. Understanding something this widespread feels like, I don't know, a necessary aha moment.
It really is. And that seemingly everywhere presence of microplastics, that's exactly what we're diving into today.
So what's the plan?
Well, we'll explore what they actually are, where they're coming from, how they get around, crucially, why you should care, and what we can maybe do about it.
All right, let's get down to it then. First things first.
Yeah.
What are microplastics, technically speaking?
Okay, so essentially they're synthetic polymer particles. Think plastic bits, smaller than about 5 millimeters, like smaller than a sesame seed.
Okay.
But wait, there's more. There are also nanoplastics. These are even smaller, less than 1 micrometer, sometimes even under 100 nanometers.
Whoa, incredibly small.
Yeah.
Why does that extra tiny size matter?
Well, that's where it gets really interesting, biologically speaking. Their minuscule size means they might be able to interact with our bodies, like at the cellular level, inside our cells.
Okay, that's something to think about. And it's not just one kind of plastic rubbish we're talking about.
No, definitely not. It's a really diverse mix. You've got polyethylene, think plastic bags, bottles, polypropylene, lots of food containers, polystyrene, styrofoam. It's a whole range.
Right, a real cocktail of plastics. And they look different too, yeah. Not all just little specks.
Exactly. Their shape or morphology matters. You get fragments, just sort of irregular, broken bits. Then there are fibers or filaments. Textiles are a huge source here.
Like from clothes.
Yeah, washing your acrylic jumper, for instance, can release thousands of tiny fibers. Then you have microbeads or spheres. They used to be common in face scrubs, but many are banned now, thankfully.
Yeah.
There are also pellets or granules, sometimes called nurdles. Those are like the raw plastic beads used in manufacturing. And foams, films, pieces breaking off polystyrene packaging or plastic bags, and even tire wear particles.
Tire wear from driving. I hadn't really considered that as plastic.
Yeah, it's a significant source, especially the dust coming off tires. It adds up. So a really key thing is where they originate. Primary versus secondary.
What's the difference?
Primary ones are made small, like those microbeads or the industrial nurdles. But the vast majority of what's out there in the environment, that's secondary. Meaning they come from larger plastic things breaking down, that plastic bottle that gets littered or the fishing net lost at sea. Over time, it fragments into smaller and smaller pieces.
So sunlight, waves, just general wear and tear breaks big plastic down into this micro stuff.
Precisely. UV light makes plastic brittle, physical action like waves, or even in your washing machine grinds it down. And microbes can play a role too, though it's slower for plastic.
And this breaking down isn't just making things smaller, is it? It changes the plastic somehow.
You're absolutely right. As you break a larger piece into, say, trillions of micro or nanoparticles, the total surface area just explodes.
Okay.
And that massively increased surface area makes it much better at leaching out chemical additives that were in the plastic originally. Things like plasticizers, flame retardants.
Stuff you don't want floating around.
Exactly. And it also makes them better at soaking up other pollutants from the environment, like pesticides or heavy metals. They basically act like little toxic delivery systems.
Wow. Okay, so where is all this stuff coming from in the first place? You mentioned clothes and tires.
Well, the vast majority, something like 80 to maybe even 98%, originates from activities on land.
Right.
Synthetic textiles, like we said, laundering them is huge, probably the biggest primary source to the oceans globally. Tire abrasion is massive too, especially in Europe and North America. It ends up in stormwater runoff. Oh, lots. City dust contains them. Road markings, shedding tiny bits, marine paints and coatings, those plastic pellets, nurdles spilling during transport, fragments from plastic films, foam breaking apart, even paint flakes, and agriculture plastic mulch film, coatings on seeds or fertilizers.
It really sounds like it's almost unavoidable, coming from everywhere. Where does it all end up?
Pretty much everywhere we've looked for it. Oceans, yes. They collect in those big rotating currents, the gyres. You hear about the Great Pacific Garbage Patch is less like an island, more like a huge diffuse soup of tiny plastic bits.
Right.
And it's not just the surface. They're found throughout the water column, right down into deep sea sediments. Estimates are millions of tons on the ocean floor.
Okay, oceans are bad. What about land?
Interestingly, concentrations might actually be higher in soils than in the oceans.
Really? How?
A big source is sewage sludge, or biosolids. Wastewater treatment plants remove microplastics from water, but they concentrate in the sludge, which is then often spread on farmland as fertilizer.
Ah, so it goes back into the environment.
Exactly. Plus, plastic mulch used in farming, irrigation water, carrying particles, litter, and even just particles falling out of the air.
Falling from the air, so they're airborne too.
Yes. Atmospheric transport is a real thing. Wind can carry these tiny particles vast distances, depositing them on land, sea, even remote mountaintops. It shows how interconnected it all is. Rivers carry them to oceans. The air carries them everywhere.
You mentioned wastewater treatment plants. Do they help at all?
They do, actually. Modern plants can be very effective, removing over 90%, sometimes even over 99% with advanced techniques. But the sheer volume of water being treated every day is enormous.
So even a tiny percentage getting through adds up to a lot.
Precisely. And then there's the sludge issue we just talked about, reintroducing them to land. So given how widespread they are out there, it's maybe not surprising we're finding them in us. How are we actually getting exposed?
That's the scary part, isn't it?
The plastic we discard today, even if it breaks down into microplastics, doesn't really go away for potentially hundreds, even thousands of years. It's an intergenerational issue. Acting now isn't just about us, it's about the health of the planet and future generations. Think about the cumulative impact of all these tiny, persistent particles.
That's a powerful thought to end on, a reminder of our collective responsibility. For everyone listening, if this sparked your interest, maybe look into local cleanup initiatives, check out water filter options for your home, or just pick 1 or 2 single-use items to phase out this week. Every little bit helps.
Absolutely.
And please, subscribe to our channel for more deep dives into topics like this. Also, check out our store for the latest articles and free cheat sheets on environmental health and well-being.
Thanks for tuning in.
This deep dive was brought to you by Medical Arts Official.